I filled out everything, so I'm going to go ahead and click next. Now you can add some additional tags to this, but basically the rest of these windows you can keep as default. We are going to roll back the resources if we fail. Now what that means, if it tries to apply something and then that fails, it will delete all the resources back to its original working state. So we're going to keep that as is. Click next, and we're going to scroll down to the bottom, and this you need to make sure you tick this, because like I showed you in the stack, we are generating IAM resources and policies in this stack, so you have to acknowledge that this is doing that. Go ahead and click create stack, and now we just have to play the waiting game. This will take probably around 5 minutes to complete, so we will come back when it's done. Okay, so it has just completed. So now we can actually head on over here to the resources, and we can see everything that has been completed. You know, from the AMIs, I mean, we can see every single resource that has been generated here. So before we get started, let's go ahead and open up this server bucket. And I'm going to go ahead and close down these other tabs. So here is where we need to upload our server code, but we need to do it in a particular format, and I'll show you why. So if we open up the CloudFormation template and open up the launch configuration, you'll see down here that I'm running an AWS Sync command, and it's looking for something called server code. And then inside that server code, it's looking for this file called servered, and I am executing that server and writing the logs to a file. So we need to generate that. So let's say create folder, say server code, and we do want to enable server-side encryption because we like being safe. And then let's go ahead and dive in here. Now I can come over to here to where my code is, and here's my entire code. I can drag it and I can drop it in there, but I would discourage you from doing that because it will probably upload around 400 kilobytes a second, anywhere from 400 kilobytes to 1 megabyte a second. And that will take you probably a solid 5 minutes to upload all your code, and my code is small, so yours, if it's like in the gigabytes, oof, that could be a rough wait. So here's what we're going to do to speed things up. So I have already installed the AWS CLI, and there are a ton of resources out there showing you how to do just that. So I'd encourage you to set up your AWS CLI so you could take advantage of the same situation that I'm about to do. So I'm going to open up the command prompt, and we are going to switch over to the D drive, and we are going to CD to this directory. And we're going to have a look at that, and here's our directory. So now we're going to run the AWS S3 Sync command on everything in this directory, and we want it to get pushed up to this bucket into the server code. And this one is hosted, I think it's US West 2. And then I'm using the default profile. I didn't set up any custom profile. Okay, go ahead and click next or enter. You'll see I'm missing something. You'll see it start saying upload failed, because this is part of that protection I added to this bucket. So if you go to the permissions tab, you'll see I've enabled all of these things, and I've also added a statement here preventing unencrypted uploads in any format. So we have to encrypt this. So I'm going to say server-side encryption AES 256, because that's what we're using in this bucket. Okay, so it's done. So now we can come over here and refresh this page, and we can see everything here is now ready to go. So now we are ready to launch our EC2 server. So we could come back in here and we can update this parameter here, this desired capacity to 1 and the minimum capacity to 1, or I'll show you how to do it just come on straight over to here. Now be warned, if you do it this way, where you come over here manually and you manually start it, it essentially gets disconnected from CloudFormation, meaning CloudFormation will still think that the desired capacity is 0 and the minimum capacity is 0, when in reality it'll be 1, 1. So just be aware of that. But I'm going to show you this this way. And before I get started, let's hop back over to Route 53, because then we can see the real-time update that is going to be happening. Okay, so remember, this is our Route 53 scenario here with this random IP that I just put in there. We are going to come up to here and we are going to say start one instance, and it will pull down that code that we just uploaded to our S3 bucket. Okay, say update, and it will say updating capacity. We can now head over here to our instances, and we just need to wait for a little bit. And we can come down here to the activity tab, and we can see that notifications have been set up that on an instance launch, it will register it with Route 53. And this is all done in the CloudFormation template that I've done for you. So we just have to be patient. Okay, so it is pending, and here is the public IP address. If we head over here, it probably hasn't updated yet. Yep, it hasn't updated. It's because it takes a little bit. So we just have to wait for this. Okay, so it is marked as running. It might have updated now. Yep, there we go. It just updated. So this is the public IP address of our instance. Now we can give out the public IP address, sure, but the better way would be to give out this DNS name to people, and then people can connect to your server with that DNS name. And of course, you can hard code that into your code as well, because then it gives you the power to basically switch out the instances on the fly without having to update the client code. So now we basically have to wait for the status check to pass, and we can be 100% sure that our server is now up and running. And boom, just like that, you have started a server without actually having to physically do any commands on the server itself. But I'm going to show you how to SSH into the server. So if you do need to do some maintenance on the server or something like that, you can. So I'm going to be using PuTTY. And if you're on a Mac or Linux, you can use the SSH command with -i and pass in your PEM file, and then it will ask you for a username and an IP address. The username will be EC2, and the IP address will be this public IP address here. So I've already done most of this, but I'm going to say load, and then I am going to copy this and paste it right here, and I'm going to go ahead and save that back. Now it's important to know that we need to include our SSH key. So I'm going to go to SSH auth, browse, and you'll notice it's looking for a PPK, but we have a .pem file. So dang, you know, we got the wrong key. But don't fear. PuTTY comes with something called PuTTYgen, and we are going to take that and we are going to load up that key, that PEM file here. So we're going to load it up here. And then we are going to save the private key. And we can add a passphrase if we want, but I'm not going to. And then I'm just going to call it the same thing, Unity server, but this time it'll save it as a .ppk. Here it is. So there's the .ppk. So now we can take that and we can load that up here. And let's just come back here to our session and verify everything is good. IP, port. Okay, let's say open. Say yes, I want to connect to this. And EC2 user. And here we are in our running server on AWS. And by default, I run your server with the root user, probably a bad idea, but let's go to the root directory. Let's just ls, and we see our server code that we put here in our bucket. Let's go to our bucket really quick, S3. Okay, so here we are inside of our bucket, and here you see all those files. And our server is actually physically running now, and you'll see that it changed it to an executable file, and it's basically running in the background. So here at the top, we see server is running. So we can now connect to it. And if our EC2 instance dies for whatever reason, our auto scaling group will detect that that instance has died, and it will automatically start a new one. It will download this code, it will start your server again, and it will update our Route 53 record for us. And so basically, you'll get maybe 3 to 5 minutes of downtime. People could lose access 3 to 5 minutes, but then 3 to 5 minutes later, without having any human interaction, people can connect again. Now, in a production scenario, now for some scenarios, that's okay. Other scenarios, you may want to do some more research on architecting AWS to your best needs. There's a lot of other things I haven't covered that you can solve this with, such as connecting a Route 53 name up to a load balancer, running multiple servers with sticky sessions enabled, having those servers communicate state between each other. But that's way, way, way more advanced than probably what you're looking for right now.